Hi, in this video we will learn about the physical interpretation of derivative and the second derivative. The model we are studying is that an object is moving on a straight path, and at every time t, we register the position of this object, and p f at t is the position of the object at time t. Well, sometimes we denote it by s. So if you have the position function, so at all times you have where this object is, then you can get all the other information. For example, the first thing that you have to know is this fact that the rate of change of position with respect to time. So if you find the derivative of position function with respect to t, this is equal to velocity of that object. It basically means that how the position changes as time varies. And while the notation we have for that is v, velocity, and rate of change means what? Means the first derivative of that function. So the first derivative is the velocity of the object, while again at time t. And then the third thing that comes in is that how the velocity changes is called acceleration. And acceleration basically is the rate of change of now velocity with respect to time. In other words, if I differentiate v, we will get what's called acceleration. But v itself is the first derivative, or the derivative of position function. In terms of position function, this means that the second derivative of position function will be the acceleration. The acceleration of the object at, again, time t. So these are the facts. So in other words, other way of asking find the second derivative, if the function is a position function, would be give me the acceleration. The first derivative is give me the velocity. And let's do some examples here. Example. The position of an object along a line is modeled by f of t is equal to 5t cubed minus 3t squared plus 4t minus 1. First, find the velocity and acceleration. Then tell us when the acceleration of the object is 0. Okay, so here means velocity means the first derivative of the position function, and that's 15 t squared minus 6t plus 4. And the velocity and the acceleration is the second derivative, which is derivative of the velocity, and this gives us 30t minus 6. That's the acceleration. So means what? Means that at every time t, for example, at time t equal to 1, the acceleration is going to be 30 times 1 minus 6, which is 24. That's a big number, but that's what we have. Okay. Part 2 says when the acceleration of this object is 0. So what means what? Means that we are trying to find t such that the acceleration at which acceleration, which is f double prime, is equal to 0. Well, f double prime here is this guy, set it equal to 0, and then as a result of that, oh, this was 30. Okay, 30t, and that's 30t is equal to 6, and t is 1 over 5. So that is when the acceleration is equal to 0. Let's just do one more example. Again, there's nothing new but the wordings that if we have an object moving with that with the position function given, then the second derivative is acceleration, first derivative is velocity. So find the acceleration of the moving object with the position function f of t is equal to t plus 4 over 2t plus 1. Okay, well, when was it? The acceleration of okay, at time, sorry, the time t equal to 1. Okay, we have to find the first derivative and then second derivative. So acceleration, we know that is at time t is the same thing as f double prime at 1. So for that we need to find f prime of this guy here. So we have to find the prime. This is quotient rule, so t plus 4 prime 2t plus 1 minus t plus 4 times 2t plus 1 prime. Then the denominator is this guy squared. Okay, so this gives us 2t plus 1 minus 2t minus 8. And these two cancel. We get negative 7 over 2t plus 1 squared. How about f double prime t? Well, we have to differentiate this guy but we can write that as this, and then we have the power rule, yes, or chain plus power rule, which will give us -2, n comes up front, derivative of the function, then the function to the power 1 less. This gives us 14 times 2 times 2t plus 1 to the power -3, which is the same thing as 28 over 2t plus 1 to the power 3. So acceleration at time t equal to 1 is f double prime at 1, which is this guy, 2 times 1 to the power 3. This is 28 over 3 to the power 3. This is 27. Acceleration at time t equal to 1 is 28 over 27. And well, that's again just new terminology, nothing new in terms of the differentiation rules or anything new mathematically. Just the first derivative of position function is the velocity, the second derivative is acceleration.